We are talking about parallel lines and proportional parts, and we want to use proportional parts within triangles and use proportional parts within parallel lines. So here we have some examples, and example 3 here is referring to the triangle proportionality theorem. And the reason that we think that is because we have two lines that are parallel to each other. So we have to kind of look at what we have. And right now we have a value question mark, which I don't like writing question marks in my equation, so I'm going to change this to x. So we have x, and then we have 20, an unknown value, and 14. Well, how could we get this value right here above that parallel line? Well, we know the full length is 28, and we know the part that is given is 20, so if we subtract them, we get a value of 8. So now we can set up our proportion, and the proportion that I'm going to use is, I'm going to set it up this way, and I always draw my proportion on there just to make sure that I don't put any numbers in the wrong location. So I'm going to put my proportion right here, and I'm going to put my values in just the same way that they are here. So I have 8 over 20, 8 over 20, and then I have 14 over x. 14 divided by x. And now we just do our means and extremes. So our extremes in this case are going to end up being 8x is equal to, and then our means are going to be 20 times 14. And then we can just go ahead and do that multiplication, and we get, on the left side, we get, still keep 8x is equal to 280. And we divide both sides by 8. And we get x is equal to 35. Next, we have the corollary to the triangle proportionality theorem. And in this case, it's not quite a triangle, so but the same principle applies. And we have 12, we have a full distance of 18, so we got to get that little piece right there. So we're going to say 18 minus 12, and 18 minus 12 is 6. Then we know that we have 6x minus 2, and we have 8, and we can set up our proportion. We can set up our proportion this way, where we have 8 over the binomial x minus 2 is equal to 6 over 12, or we can set it up this way. Either way works. I'm going to choose to set it up this way. And so on the left side, we have 8 divided by 6x minus 2. And that's going to be equal to 6 over 12. Well, we can do our means and extremes again. And our extremes are going to be 8 times 12. And our means are going to be 6 times the binomial, 6x minus 2. And those are going to be equal to each other. So on the left side, we have 8 times 12, which is 96. and that is going to be equal to 6 times 6 is 36x, and 6 times negative 2 is negative 12. So then we can add 12 to both sides of the equation, and we get 108 is equal to 36x. Divide by 36, and we get x is equal to 3. Then we have another example for triangle proportionality theorem. This one is a little bit more complicated than the last two. We are given 1, 2, 3 sides that we know, and then we're given an expression for the total distance, but we still need to figure out what that piece is right there. We're going to do it the same way. Say 2x plus 16, and we're going to say minus 20. Now we can only subtract 20 from 16 because these are both constants. We can't do anything with the 2x, so we just bring down the 2x. 2x minus 4. So that is this value right here. And then we can set up our proportion. And again, we could set it up this way. We have 15 over 20 is equal to, set it up this way. We have 15 over 12 is equal to 20 over 2x minus 4. But I'm going to set it up this way. So our values are 15 over 12, and that is equal to 20 over 2x minus 4. Again, we have our means and extremes. So we have our means are going to be 12 times 20. That's going to be equal to, and our extremes are going to be 15 times 2x minus 4. Then we can do our multiplication. So 20 times 12 is 240. And that is equal to 15. We have to distribute that in. So we get 30x and negative 60. Then we can add 60 to both sides of the equation. And we get 3, cancel there, so we get 30x. And that is equal to 300. And we have one step to finish up. So we have 300 is equal to 30x. Divide by 30. And we get 10 is equal to x.